Welcome to this video. In this video, we are going to draw the graph of the function that you see here on the screen, and we're going to take into account the domain of the function, the sign, and limits at the boundary points of the domain of f. And once we have collected all these pieces of information, we are going to draw a qualitative graph of this function f. So let's start. We start by the domain. So as you can see from the formula here, we've got a log and we've got a denominator here. So we've got to take into account about these two parts. First thing, log x. So if we have log x, you remember that we need to have that x has to be positive. So this is the first condition. Now in the second part of the function here, we've got this denominator. So we've got something divided by x minus 1 squared. And so this implies that the denominator has to be non-zero, so x has to be different from 1. And so now you put these two conditions together, and we obtain very simply that the domain of f is equal to the open interval 0, 1 union the open interval 1 plus infinity, namely all positive numbers, and this is this condition here except 1, this condition here. So if we want to represent this set in the real line, so this is the real line here, we've got 0, we've got 1, and so the domain of f is nothing but this half line excluded 1 here. Good. So we've got the domain. Let's move to the sign. So we want to understand where this function is 0, where this function is positive, and where it's negative. So let's start by writing the expression of this function again. So this is log x over x minus 1 squared. So if we look for the x's for which this guy is positive, well, you just notice that the denominator here being a square, this is always positive. So this is positive if and only if the numerator of this fraction is positive. And then you just solve this inequality here. When is the log positive? Well, if and only if x is bigger than 1. Then you apply the same reasoning. When is this 0? Where is this function 0? Well, if and only if the numerator is 0. So even if and only if the log is 0, and which happens if and only if x equals 1. Last condition, when is this function negative? Well, this is just a consequence of the two above conditions. It is negative if and only if x is smaller than 1. So the sign is done. We know, let's look at here the domain that we've drawn before. So here the function is negative, and here it's positive. Now, are we forgetting something? Well, yes. Actually, what about this line? Well, if we are careful, you notice that what we got here, x equals 1, is not in the domain of f. So this is just a double check we are doing. And so this case actually is not applicable because it's not in the domain. Of f. So we should not consider this case at all. Okay, so the sign is done. Now we had to do domain done, sign done. Last thing is limits, and then we do the graph. So let's calculate the limits of f at the boundary of the domain. So what does it mean, the boundary of the domain? Well, let's look again at the domain here of this function. Doing limits at the boundary means that I have to do a limit here when x approaches 0 from the right. Then I have to do a limit here when x approaches 1 from the left, then here when x approaches 1 from the right, and then here when x goes to plus infinity. So let's do this for limits. Let's start by the first one, which is the limit as x goes to 0 from the right of log x over x minus 1 squared. And it's helpful to look at the numerator and the denominator separately. So let's look at the numerator first. So this guy here, the log in 0 goes to minus infinity. So that's easy. And the denominator is easy too, because I have x minus 1. When x goes to 0, this goes to minus 1 squared, and so this goes to 1. So this limit is very easy. Now you just use the rules of limits, and I have minus infinity over 1. This gives me simply minus infinity. And now I can just look at here and see, is this consistent with the sign I had before? And yes, it is, because for x between 0 and 1, the function was negative. So this, at least the sign here is okay. If I had obtained plus infinity here, well, in this case, there would have been a mistake either here in the sign or here in the limit. But now I know that at least these two results are consistent with each other. Okay, so we did this case here. Now let's focus on this case, so the limit to 1 from the left. So let's calculate the limit as x goes to 1 from the left of log x over x minus 1 squared. Let's do as before. Let's consider the numerator and denominator one after the other. So what about log x? As x goes to 1, this goes to 0. And the denominator is actually the same. So they both go to 0. So we cannot conclude from here. We have to keep going. And how do we keep going? Well, we separate the denominator into two parts. And so let's do the following. Let's rewrite the limit. So we write this fraction as log x over x minus 1 times 1 over x minus 1. So why do we do it? Well, it's simple, because this is the usual limit, log x over x minus 1, and this is well known. This converges to 1. So this is easy. And now what about this? Well, this goes to infinity as x goes to 1, because the denominator here goes to 0. We just need to understand what the sign is, but since x goes to 1 from the left, this guy goes to minus infinity, because the denominator is always negative. And so I get 1 times minus infinity. This is minus infinity. For exactly the same reason, the corresponding limit as x goes to 1 plus of f of x is plus infinity. Why? Because this guy here still converges to 1, while this part here goes to plus infinity. Okay, so let's double check whether this is consistent with the sign. Yes, it is, because from the left we got minus infinity, and it is consistent with the minus, and from the right we obtained plus infinity, and it is consistent with the plus. Okay, last limit is the limit as x goes to plus infinity of my function log x over x minus 1 squared. Now let's play the usual game. The numerator goes to plus infinity as x goes to plus infinity. The denominator does the same. This is plus infinity over plus infinity. In principle, we cannot conclude immediately. However, we need to recall that the log goes to infinity with order very small. In particular, it goes to infinity with order less than 2, which is the order of the denominator. So in some sense, we can say that here the denominator wins and the numerator loses the game. And so in this case, if the denominator wins, it means that we have something like the plus infinity in the denominator, and so the result here is nothing but 0. Okay, so the limits are done. Okay, the last part is the graph of f. So the game here is to collect all the pieces of information we've collected so far, so the domain of f, the sign of f, and the limits of f, and put all these pieces of information together to draw a qualitative graph of f. So let's start by drawing the axis. So this is the x-axis and the y-axis. So I ignore the negative part of x, since I already know that the domain is the positive real axis except 1. So 1 in this game is excluded. So this is the domain of f. Then I recall that here the function has to be negative and here the function has to be positive. So this is the second part. And then finally I have to use the limits. So the limits, so let me remove 1 from the domain. Let me do this because I have a vertical asymptote. And the limits are minus infinity in 0, so I have this, minus infinity in 1 from the left, plus infinity here, and 0 at plus infinity in the x. And now basically I just have to connect these parts of the graph in the most likely way. So the most likely way is the following. Here it is, and here it is. Thank you very much for watching.